Okay, here are these extra practice problems. So hopefully you tried them on your own, and now you're just ready to check the answers. So again, I'm not going to solve and show you the whole, process. I'm just going to give you that final balanced equation answer. Okay, so let's see here. Our first one, you're going to get... Okay, so this is what this one should look like. All right. Sometimes my Apple Pencil doesn't pick up all the time on my iPad. Okay. This one's pretty crazy, this explosive decomposition of dynamite. So we're going to get a single reactant here. And this one's a little bit tricky. So if you had a little bit of problems with this one, keep giving it a shot because it's a little bit trickier. But here we go. You'll get a coefficient of 4 in front of your nitroglycerin. Okay, and you're going to get 12 carbon dioxide plus 10 water vapor. There we go. 6 nitrogen gas, and again, gotta remember those polyatomics, or the diatomics, so nitrogen gas is N2, and then an oxygen gas. And oxygen is another one of those diatomic molecules, so you need to know that. Okay? All right, next up, we've got some copper 2 oxide reacting with ammonia, so you should get this. There's that N2 again. All right, then we get this lead 2 nitrate. Okay, and we're going to get some lead 2 chromate. Okay, and it says that that forms a yellow precipitate. So a precipitate is that solid that comes out of solution. Okay, and we have that potassium nitrate that stays in solution. All right, and then our last one is this hydrochloric acid. All right. Okay, so there's that set of practice problems. All right, next up. Okay, we've got some zinc reacting with hydrochloric acid. And there's that hydrogen gas again. Again, don't forget that hydrogen exists naturally as a diatomic molecule, so hydrogen gas is H2. All right, then we get some potassium chlorate. Okay, now it says when heated, so we could, if we wanted to, put that little symbol above the arrow to know that there's heat there. You don't have to put it there, but that just indicates that it's being done under heat. Okay, let me get that too. That's our potassium chloride. And again, oxygen's another diatomic. So oxygen gas is O2. All right, and then we've got some hexane burning an oxygen gas, giving us carbon dioxide and water. So this is a combustion reaction. So anytime we burn something in oxygen and we get carbon dioxide and water vapor as our products, that's a combustion reaction. So usually when we do combustions, it's a hydrocarbon or it's some type of alcohol usually. We can combust other things, but a lot of times we combust things are hydrocarbons or alcohols because they burn easily. All right, so hexane. Yep. Writing too fast there. Don't want to forget my gas. And then we're going to get 12 carbon dioxide. And then these are done under heat, so we should get water vapor there instead of liquid water. Okay. So the hint on combustion is always balance the O2 last in the reactant side. I usually start by balancing, I usually start by balancing the hydrogens. So I look over at my hydrocarbon and I had C6H14. Now here's the thing. On my product side with these, we have H2O, which is a single oxygen. So if I were to put an odd number in front of there, I end up with an odd number of oxygens. On my reactant side, I only have O2, and I'm dealing with a hydrocarbon like this. And so if I have an odd number of oxygens on my product side, I'm never going to balance it. So I always have to make sure I put an even number in front of the water. So I look at the number of hydrogens. Well, H14, if I divide 14 by 2, I get 7. 7's an odd number. I can't do that in front of the water. So I put all 14 there. And then 14 times 2 means I need 2 times the 14 on the other side. And so that's how I start off balancing those. And then I always do the oxygens last. Okay, just a few more. Okay, acetic acid. So this first one, this is the baking soda volcano reaction when you do vinegar and baking soda, and you get all the fizzing and stuff. This is the reaction that's happening when you do a baking soda volcano. All right, so there's your vinegar and baking soda. And this one's actually already balanced as written. So the vinegar and baking soda reaction is actually an acid-base reaction. And it ends up being done in a very nice, very easy to deal with 1-to-1 ratio. All right, and then we've got this ammonia one. All right, and 2 more. Okay, and then we get some iron 3 chloride. Back. Stay. There's the ammonium hydroxide. Remember, when we have a polyatomic ion, we have to keep the whole thing together, so that's why I have the hydroxide in parentheses. All right, and last one, get some barium hydroxide. And we get some ammonia, some water, and some barium chloride. Okay, all right, so practice. You gotta try these. Don't just write down my answers and be like, oh yeah, I can do that. You actually need to try these, otherwise you won't master it.